Well, as I said, the summary of a stoichiometry calculation looks like Greek letter pi, a balanced chemical equation, what we're given and what we're looking for. I use chemical 1 to represent the chemical we're given the information for. I use chemical 2 to represent the chemical we're calculating for. I want to emphasize chemical 1 can be either a reactant or a product. Chemical 2 can be either a reactant or a product as well. In other words, it doesn't matter whether they are reactants or products. The calculations are extremely similar to each other. There are 4 typical stoichiometry calculations in general chemistry. When I say typical, I mean most common. The 4 typical stoichiometry calculations, or the 4 most common stoichiometry calculations, are listed here. The first kind is we are given the moles of one chemical. We are calculating the moles of another chemical. The second kind of calculation is we are given the moles of one chemical. We are calculating the grams of another chemical. The third kind of calculation is we are given the grams of one chemical. We are calculating the moles of another chemical. The last kind is we are given the grams of one chemical. We are calculating the grams of another chemical. The first kind of stoichiometry calculation is the easiest one. It only needs a single-step calculation. The last kind is the most difficult calculation. For all 4 typical stoichiometry calculations, it needs at least 3 steps to finish the calculation. The second kind and the third kind are similar to each other. They are less difficult than the last kind, but they are more difficult than the first kind. In addition to the 4 typical stoichiometry calculations, we may have additional stoichiometry-based calculations. A problem may involve stoichiometry and 1 or 2 of the following calculations: density, molarity, standard enthalpy of reaction, ideal gas law, PV equal to nRT. If every combination is considered, we can have 31 more calculations in addition to the 4 typical stoichiometry calculations in Chapter 3. When you heard the number 31, do you feel scared? I believe you may, but don't worry. Let me tell you the trick. If you master each individual calculation skill and the general procedure to solve stoichiometry-based calculations, you should not have a difficulty to get the solutions of all calculations listed above. When I say individual calculation skill, I mean density calculation skill, molarity calculation skill, standard enthalpy of reaction calculation skill, or ideal gas law calculation skill. We will learn them in different chapters: Chapter 1, Chapter 4, Chapter 5, and Chapter 10. We are learning the general procedure to solve stoichiometry-based calculations right now, so make sure you pay attention, you understand them. When I say all calculations, I mean 31 plus 4 equal to 35 calculations. If you master each individual calculation skill and the general procedure to solve stoichiometry-based calculations, you should be able to solve all 35 calculations. By the way, when we combine stoichiometry and molarity calculations, they are called titration calculations. Although in the name it doesn't say stoichiometry, actually, titration calculations are stoichiometry-based calculations. Do you believe me?